Okay, let's learn some recursion. So, what is recursion? Recursion is when a function calls itself. So, as an example, you might have a function called func, and for this function to be recursive, it would have to call itself, func, invoked, somewhere inside of the code block here. Now, all recursive functions will have two cases inside of their code block. There will be a recursive case, which is where the function calls itself, and there will be a base case, which will not call the recursive function, but instead will just return a value. So the best way to understand this will be to do an example. Let's write a function that will take in a number and return the factorial of that number in a recursive way. If you're not familiar with what factorial is, the factorial of a number is simply that number times every number from itself down to 1. So the factorial of 4 would be 4 times 3 times 2 times 1, which equals 24. So we say that 4 factorial is 24. And as another example, 3 factorial would be 3 times 2 times 1, or 6. Okay, so let's write our factorial function. We will say function factorial and it takes in some number, num. Inside of our function, we will have an if-else statement. Now, this if block up here will be our base case. And this else block will be our recursive case. So let's start with the base case. How a base case works is basically we say, what is the situation in which if I take a parameter that I can simply return the same parameter and get the correct output for our function. So for our function, what is the case in which we can take in a number and simply return that number to get the correct answer? And the answer is 1. So we say that our base case is when num equals 1. If we take in 1 as num, we can simply return num because 1 factorial equals 1. That doesn't work for, say, 4, because if we take in 4, we should output 24, not 4 itself. Great, that is our base case. So now we have to deal with the recursive case. So we will say, if num does not equal 1, or simply else, we will want to return num times factorial of num minus 1. And this is where we are calling our function inside of itself, causing the recursion. And that is it. That is our function. Now, how the heck does this return the correct answer for us? The best way to explain this is by running through what the function does step by step. To visualize what is happening in our function, we will use the call stack. If you're not familiar with the call stack, what it does is it represents what order our functions are being called in and what variables they are being called with. So our call stack will show us how this function will call itself and what happens at each step. We will depict the order our functions are called in, or our call stack, as a simple stack of blocks on top of each other. Now, let's run through our function with the example of 4 to see how it works. The first thing we do is call our function factorial with the number 4. And we will depict what happens in this function in the block on the left. So in this function, num will be equal to 4. So we have to go into our else statement, and what do we return? Well, we return 4 times our factorial function being called again with num minus 1, or 3. So now we call factorial of 3, and in this function, num will equal 3. And since num is still not equal to 1, we will have to return 3 times factorial of num minus 1, or 2. Now we call factorial with 2. In this function, num is equal to 2, and we return 2 times factorial of 1. Now we have our special, or base case. So here is our factorial function being called with the number 1. We come into the function and enter the first if statement, because num equals 1. In this if statement, instead of calling our factorial function again, we are simply going to return num, which is the value 1 right now. Now, what you will notice here is that since we are no longer going to be calling the factorial function that we are currently in, or in other words, we are no longer going to be making recursive calls, you will see the call stack start to unwind, and everything will start to make sense and come together beautifully. So this top function will simply return 1 to the function that it was called from. Then this expression becomes 2 times 1, which evaluates to 2. So now 2 is returned to where it was called from. This evaluates to 3 times 2, so we return 6 to the function below it. And finally, in our initial function, we end up with the expression 4 times 6, which evaluates to 24. So, as you can see, in a recursive function, we keep building up the call stack until our base case is satisfied. Then we unwind the call stack by returning the value of each function call until we get to the initial function call. Then we simply return the value we are left with. And that's it. That is how recursive functions work. Now, if this is the first time you are being introduced to recursion, you may still be a little confused, and that is okay. The main idea that you should take away from this video is that a recursive function will continue to call itself until the base case is satisfied. If you don't fully understand recursion yet, don't worry. We are going to be working with recursive functions in our binary search tree, so we will get a lot more practice with them, and they will become a lot more clear as we move on. Knowing recursion is a great skill set to have. And just as a side note, our factorial function would still work if we set our base case to whenever num is less than or equal to 2, instead of whenever num equals 1. Setting our base case to whenever num is less than or equal to 2 would essentially stop our factorial function from being called with the value 1 as num for larger inputs. This would work because multiplying by 1 in our last call to our factorial function is unnecessary, since anything times 1 is just itself. In this video, I decided to set the base case to whenever num is equal to 1 so that we could focus on recursion instead of factorials. But with either base case, we would get the correct answer. Great! Now we know some recursion and we can get started building our binary search algorithm. Let's code it out in the next video.